Hey class, how you guys doing? Doing well. Um, Feeling good about your work yesterday? What I see is I see lots of evidence of good learning. You know, lots of people. I'm like, wow, you guys really did learn a lot this semester so far. Um, so today, what I want to do today is maybe stimulate some ideas for the for your end of semester project. I hope that at least some of you are already coming up with ideas and starting to look for data out there in the world. So remember, if you find data tables that come along with latitude and longitude coordinates, you can enrich other feature layers that have representation of those coordinates using tools in ArcGIS Pro. So we did some of that. I showed you some government databases and using join commands or using the create features from XY data in a table. You can create features from that data. So we've been doing a lot. I've been doing a lot of additions to the review slide deck that is posted on Google Drive. So this is the slide deck that is linked to in pretty much every week's lesson this semester. And I've also divided it into part 1 and part 2. Why? Because the topics that are in the part 2 of that slide deck are going to be in the exam. And the exam was scheduled for Monday, and as we talked about earlier this week, decided to move it till Friday of next week to give you a little extra time to prepare for it because you've been focused on your practical exam. All right, so I want to show you some data today that may be useful for some people. At least one person is thinking about doing a project that involves an analysis of land use and relationship to nutrient enrichment of a creek that runs through Hagerstown. And so let's look at a couple of things that might be of use to you guys. All right, we'll come to here. Okay, so one thing that is available are, of course, all this data that's out there and hosted on Esri servers, whether it's produced by individuals, and there's lots of great data out there that's produced and shared by individuals, and the Living Atlas tends to be data sets that are curated by Esri and updated by government organizations like the USGS. So there is a data set out there of, and let's just search for NDVI. So NAPE is a program, a National Agricultural Imaging Program. That might be what it stands for. Shoot, what does NAPE stand for? It's National Agriculture Imagery Program, NAPE. So this is not satellite data. This is data, high resolution data, that's gathered from aircraft. And it's, well, it should update eventually. Let me zoom out again. So this is a processed version of the NAPE data. So NAPE is, the native form of this NAPE imagery is like full color satellite imagery, a lot like the Landsat imagery. So you can look at RGB, visual color band imagery of areas of the country. But this is a processed version of the NAPE imagery, and so what you're seeing here is NDVI, Normalized Difference Vegetation Index. And so the NDVI is then classified into, I think there's 255 classes, 256 classes if you include 0. And so in this way of classifying this data, 255 means greener and 0 means not very green at all. So if some of you, and you see this is a tile set that when you zoom in you get higher resolution tiles of the area. So let's just zoom in here on, we'll zoom in on Shepherdstown, shall we? There's our little town. So it'll take a while here to buffer and load, but there we go. So you can the color scale that's used here is low values for NDVI are red and yellow and oranges, and higher values are in the hundreds. And so what you're seeing is all of the surfaces that tend to be impermeable to rainwater, well, in the river, are reddish color. And so this could be useful if what you want to do is quantify the fraction of land cover that is impervious to rainwater, and that would lead to more runoff. You might use this data set as an estimate, or if what you're interested in is vegetative cover, NDVI is the way to go. So one thing you can do is if you zoom in, this data set is huge, and if you zoom in you get high resolution tiles for the area you're looking at. Oh, I shouldn't have moved. And if this is the focus of your study area, one thing you can do is just highlight the region that you're interested in, or zoom your map to the extent that you're interested in, and then right click on here, and you should be able to do data, export raster. And so the output raster will, use the default, no transformation. Clipping geometry, what we'll do is we'll select current display extent. Okay. And leave all the compressions the same, and then click export. And it shouldn't take too long. It's not a huge amount of data here. But what this is doing is it's clipping this data set, which is actually national, to, it looks like it was done successfully. It's clipping this data that's national, so let me take this off to just this extent. Okay. But you still got tile sets, so if you zoom in you see the resolution still updates. Well, let's zoom in on, here, this is Bird Science Center. So you see all these rooftops are red, low NDVI, and then the grassy areas are green, higher NDVI, and the paths are somewhere in between. So it's a cool data set, all right? So this was, just go to Living Atlas and search for NDVI. It was this first result. Here's that same imagery, but with natural color instead of, we put that on our map here. Here it comes. So this is just natural color imagery, and it's really high resolution. If you wanted, put this, if you wanted to just get the same spatial extent of this imagery data set from which the NDVI is based on, you could use, anybody know what tool to use? Extract by mask. extracts the cells of a raster that correspond to the areas defined by a mask. So we use this in the vineyard problem that we were working on, which we extracted by mask, and the mask was a polygon, but you can also use a raster as the mask. So my input raster here would be this nape imagery, and I'm going to use this clipped version of the NDVI version of that to mask out the rest, and then the output is going to be a TIFF. TIFF is an image format. It's used a lot in GIS. It's working. It's crunching numbers. Oh boy. This felt like a long week. Here we go. Okay, it's done. So then I'll remove that data from the cloud, and then we have left is this. So now we have both of these data sets, and they're on here at the same time. So I used this as a mask to clip out the portion of the nape imagery that's the same geographic extent. Okay, extract by mask. It's a fun tool. All right. What else do we got? So there. Well, let's go over. What about imagery that you find somewhere else? Imagery that's not in the Esri catalog. And so here's something that might be useful to some of you. So there's this data set out there that has data from the NLCD, National Land Cover Data Set. I think that's what it stands for. Yeah, NLCD. Let's take a look at this. And so we zoom in here. We'll zoom into the same area. And what we see is this is satellite imagery that has then been processed, and each pixel's been assigned to a class. And the resolution isn't nearly as high as that nape imagery. But all right, so we're looking at the 2016 CONUS land cover data set. And here's the legend, okay? So how many classes are here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. I count 21 different classes. So this this data has taken satellite imagery and processed it to assign each pixel or each cell in this data set to one of these classes. And you notice these classes correspond to different land use, different land uses. And so red are developed, so that means buildings and roads and parking lots and that sort of thing. And you have forests. You even have a class for lichens, but that's Alaska only. I guess that's and mosses, tundra thing maybe. Cultivated crops, pastures, hay. And so in the Shepherdstown area here, you see a lot of that, the yellow pasture hay. And what's this light green? Deciduous forest. So each of these, but you know, this imagery, you want to get this into your GIS to analyze it. And so let's say that you want to study this area of Shepherdstown, and you want this land covered data to work into your analysis. How do you get this data from here into ArcGIS, and it's not so bad. There's probably more than one way to do this, but what I want to do is draw a, what does it say? A box has not been drawn. No crap, I'm working on, okay, there we go. So I click this button, and now a cursor appears, and I can draw a box on my map. Okay, and now I should be able to, let's see, what data do I want here? Looks like I can get tree canopy data, 2016 on land cover. Yep. You can even get a data set about impervious surfaces. Okay. I guess I don't have those ones turned on here. So you can get one of these products or all of them at the same time. And then they want you to put in your email address. So let's do that. I'll put in my email address here. Oh. This isn't a huge amount of data, so hopefully it doesn't take too long, but I'll hit download. And it says, I don't know if you can see this, but it says the download request has been sent, and you'll receive email notification when the data is ready for you to download. And it says it will take about 24 hours. But I bet it won't take that long. I'll keep my inbox open, and maybe we'll hear a ping. So I bet this will only take a couple minutes. So if you were wanting to use data like this in your analysis, and what you're interested in is like all of the area that is associated with certain classes, you could use that reclassify tool that we use. Did you hear that? Yep, that's it. It's in. All right. So I'll go to my inbox now. And I'm sure if I was trying to pull data for a larger geographic extent, I'm sure it will take a lot longer. Okay, it says it's ready to download. It's downloading now. That was quick. All right, I'm going to drag it here on my desktop. And it's a zipped archive, so I'm going to extract it to my desktop. And it's done. Okay. Let's take a look here. So it's right here. This is the directory. All right. So this is the data, the raw data that I just downloaded. So you can see there's files in here that are labeled impervious, land cover, tree canopy. So it's the things that I requested. And we got TIFF files, those are images, and we also got XML files. This is data that goes along with those images. And it kind of looks like the structure of a geodatabase. It's just a directory. So let me go in here, and I'll go to the catalog, and I'll add a folder connection to this folder that I just created, and it's on my desktop. And here it is. Okay, now if I peek in that folder, I should see there's all those files, but you can see all the that's the icon for a raster data set. No, it's kind of tiny. It's like a little rectangle with blue and white cells on it. So let's see, we can add these then. Let's try this one, 2016 land cover. We can add this to my current map. There it is. So I'll turn off those other TIFFs that we just got. So that's the data that I just exported from this data set. Why does it look the way it does? I mean, why is this rectangle somewhat rotated? Anybody know? I closed my browser window that had the data tool in it. The box. So what's the explanation? Maybe not why does it look this way, but what's the explanation for why it looks rotated here compared to the way it did when I was getting it from the web? It obviously matches up with the landscape. The base map, the features on the base map line up with the features here. So it must be a different projection. This data was projected by ArcGIS Pro on the fly into my map here, and the projection of this data in the Data Explorer in the web browser that I just got it from must have been different than the projection that my map is using. Different projections, right, Alexis? So that's no big deal, though. I mean, I got the area I want, and ArcGIS, in this case, and hopefully most cases, can reproject that data on the fly. And if you want to reproject this image to a different coordinate system, there's a tool for that as well. I mean, permanently reproject it, but it's displaying correctly here. There's the Potomac River. So what you don't have here, though, I don't think you have it. Wow, so you got all these classes in this data set. Most of them are colored black. So you got some classes here. Let's click on a cell here. So this says color map pixel value 41. So all these are 11s. So the thing that I don't have here is the meaning of these different pixel values. So that might take some work to figure out what the different pixel values mean. I mean, we know from the legend in the Data Explorer that the reds mean impervious surfaces. But here, the classifications aren't exactly the same. This is these red pixels here are have color map pixel value 23, and these are 24, 22, 21. So all those 20s are in the neighborhood of the developed areas. And then the greens are in the 40s. Yeah, 41, 42. What's this one? 43. And the yellows are in the 80s for some reason. And the blues are in the 10s, the teens. So there'd be a little bit of work to figure out what each pixel value means. But it could be done. Okay. So there's other tools out there where you can get data. Let me show you one more. Raster data, that is. This is all raster data. There's places where you can get polygon data, line data, point data, vector data sets, and ArcGIS Online is a good place to get data, but you'll find just do a Google search for, I don't know, maybe you're interested in the locations of the tributaries of the Susquehanna River. I bet there's a polygon. I bet there's a vector feature class out there that you, or a shapefile or something out there that you can just download and use if you want to lines to represent the tributaries of the Susquehanna River. I bet it's out there already. Just got to search for it and find it. USGS Earth Explorer is another good resource for getting imagery. So the Earth Explorer, you do need to log in. Oh boy, can I remember my login? Let me try. First time. Okay. So let's see. What kind of data sets do we have here? We got aerial imagery. So the NAPE imagery is in here, plus a bunch of other stuff. Landsat imagery is in here. Here it is, Landsat. You got to drill down. Landsat Legacy. Now, Collection 1, it'll be the newer stuff. Here, Collection 1, Level 1. There's Landsat 8. So you could select that to get land. Let's keep that selected. What else is in here? Sentinel. Sentinel is a synthetic aperture radar. What's this? What's vegetation monitoring? MODIS, NDVI, another NDVI data set. Digital elevation models. Digital elevation models are here, so you can get elevation data. All right, so we'll just keep the Landsat selected, and then let's see if we can. There's this base map here. For the sake of consistency, let's zoom in to the Shepherdstown area here. And so the way this works is you got to set search criteria, and so we're not searching based on feature location. I guess you could put in like the town of Shepherdstown, and then it gets it determines the location of that feature using geocoding. But instead of doing that, let's just use, like we did before, the extent of my map here. Zoom in a little more. So down here I can say, use a polygon that is the shape of my map. So it creates a polygon in the extent of my map. I just zoomed out so you can see it, but that was the extent of my map when I selected it. And then what else can you do? You can select the date range. So maybe I'm just interested in data from, I'm not sure how recent the data is in this category. So let's go back a year. All right, January through today. And you can order by cloud cover. So maybe you only want cloud cover, days when it was less than 20% cloud cover. So you can change that, and then let's go to results and see what we get. So it's searching. So I get all these products. So this you can see. So here's an image that was. This is a Landsat. Well, they call them scenes. Landsat scene, and it was acquired on October 17th, 2020. So this is the, looks like it's ordered from newest to oldest. You can go back in time, and you can download it. So you can download this scene, and it includes, like, there's the Chesapeake Bay, so it includes the area that I had selected here, Shepherdstown, but of course it includes everything else too in that scene. So why don't we download that one? So let's see, which one should I pick? Probably this one. Well, that's a big file. Holy smokes. I'm not sure what the difference is between these other products. Maybe, well, what's probably happening here is these are processed versions of the scene. My guess is that the natural color image is only going to have RGB bands in it, so you wouldn't be able to calculate something like NDVI from that data. Let's download it and see what it looks like in ArcGIS Pro. So it's downloading. It's only 18 megabytes. That's funny, it says 8.1 here, but the actual size is 18. Huh. Okay, and it's a JPEG. So there it is, okay? So I don't think this even has Shepherdstown in it. Here's the Potomac. Yeah, I guess it does. Just that little tiny piece up there. There's Shepherdstown somewhere right up here. There's Harper's Ferry. There's the Shenandoah. There's the Potomac. So this isn't going to be, this is a nice picture, but this isn't going to be something that we can put into ArcGIS and analyze. It doesn't have coordinate systems associated with it. But it is really nice. Look at that. That's a pretty nice product. It's got the orientation correct, so up is north. It's got nice NASA and USGS logo. It's the sort of thing I'd want to put on my wall. It's pretty high resolution too. Okay, but that's not gonna, you can see the clouds, so it's low cloud cover day, but that's not gonna help us in doing an analysis. So GeoTIFFs are images which have some sort of coordinate system associated with them, and so that means that they have a spatial reference frame. And I don't think I'll download this right now because look at the size, 861 megabytes. That'll take too long. So here's the Landsat look images with geographic reference. Let's try that. So if it has a geographic reference associated with it, we should be able to open it in our GIS. So I'll bring that to my desktop here. It's in a zipped archive right here. So let's extract that. There it is, extract it. Okay. And so these are TIFF images. Okay. And where did it go? I forget, I don't know where I extracted it to my desktop somewhere. Oh, it is here. Okay, I see it. Okay, let me take a look. Okay, so I'm in my GIS and let me add that folder connection. So it created a folder on my desktop called, well, hold on, gotta refresh. There it is. Okay, and let's open this up. So I get three different tips. So I get this, I guess T1 stands for Tier 1. QB stands for, I think, quality bands, and TIR, something infrared. So let's just pull one of these TIFFs onto our map here. And there it is. Okay. So, and it is, so the fact that it has a spatial reference, geographic coordinates, means that ArcGIS Pro knows how to render it here, and the features line up. You can see here's the Susquehanna River. It lines up with the Susquehanna River on the base map. So let's see here, make that smaller. So this particular TIFF, this first one is just the red, green, and blue bands of the imagery. Remember, Landsat imagery has 9 different bands that scan different, that span different sections of the visible and also infrared spectrums. And that includes near infrared, which is used for things like NDVI, but also some far longer wavelength infrared, which is called thermal infrared and is related to temperature. So maybe that's what TIR stands for, thermal infrared. Quality bands. What's in there? I'd have to do some research to see what this is showing me. Turn those two off. But there's the color Landsat imagery. You might want to, NAPE imagery tends to be higher resolution. So if you're trying to make a map that, what did I do with my NAPE? There it is. So if you're trying to make a map that you can zoom in really close to the ground, so this NAPE imagery has like 1 meter resolution, and that's kind of hard to beat. So I mean, you can make out individual cars, and 1 meter is probably not enough to make out people. But it's pretty high resolution. So this would make for a nice base layer on a map. I wonder what's going on up there. Look at that. There's like this little swath that looks funny. Obviously, it's been mosaic together. These are different images that have been mosaic together. But who knows what's going on there. It's such a weird little swath going through there. And there's Shepherd Stadium. All right, so that's it for today. All right, but so what you're looking for is if you want raster data, there's a ton of it out there, and you just gotta search for it and get your hands on it. All the stuff that I'm showing you today is freely available. You might need to create an account in order to download it with the USGS Earth Explorer service. You do have to do that. But after that, it's freely available. Sorry. And if you get imagery, usually what you're going to be looking for is TIFFs. All right, TIFFs are capable of having a geographic coordinate system attached to them, so that means when you pull them into ArcGIS, they'll be rendered correctly in your map. Frankie, did I get your email? I did get your email, yes. So, and there are some attachments to it, so I have that stuff. All right. So you guys have a good weekend and study. I'll be adding a little bit more to the review slides, not too much though. Your exam for next Friday is about 80% done. I still have some more questions to write, but just like the first exam, I'm basing it on what I'm putting in that slide deck, or I should say, what's in that slide deck is the corresponds pretty strongly with what I'm going to test you on. All right, you're going to do great. So have a good weekend, and I'll see you next time.